Hello everyone, welcome to another webinar session from Factina. We really appreciate and thank everyone for taking the time and joining us in this webinar session. My name is Prasad and I'm Customer Success Manager at Factina. Today we are going to discuss about leveraging IoT and AI for advanced asset reliability management. For those who have been part of our previous webinar, we are glad to have you back. And for those who are joining us for the first time, I would like to take a moment to provide a brief introduction to Factina and our offerings. Factina is a leading provider of industrial software solutions for Industry 4.0. Fogwin is our platform for asset operations and reliability management. With a global presence, we operate in India, Europe, and America. Mr. Hariharan Ganesh, who is the founder and chief architect of Fogwin platform, who will be presenting this webinar today. Before getting started, a quick note to all. If you have any questions, you can ask your question in the chat box, which will be answered toward the end of the webinar. Also, a recorded session of this webinar will be available in Fogwin YouTube channel soon. For those who are watching the recorded session of this webinar, you can post your queries in the comment section on our YouTube channel, and we will be happy to answer them all. Without further delay, let me quickly hand over to Hari. Over to you, Hari.
Thank you, Prasad. Hello, everyone. Good morning, good evening, good afternoon, wherever you are connecting and watching. So this webinar session is a continuation of our previous webinar. We conducted a webinar on the asset reliability management a few months back, and we talked about the basics of asset reliability management and how do we do that in the previous webinar. If you haven't watched the previous webinar, you can probably watch the previous webinar as well, either before or after this webinar. So today we are going to talk about advanced level, little more advanced level by using IoT and AI technology, how we can leverage the two major technology that are available today and how that can add value to the reliability management practice. Before we go into the advanced level, just to step back and look at what reliability management means today. So reliability management is a practice which followed by systematically managing the physical assets by understanding asset availability, usage, productivity, performance of the asset, and health conditions. Based on that, manage and execute maintenance operations to increase the reliability of the asset for the business continuity. In this traditional practice, this has been there for quite some time, but it is traditionally being followed in a manual approach by, of course, the process is to identify the business critical asset, which are crucial for business operations and productivity, and identify the maintenance plan, prepare a maintenance plan, which probably at that point it's an ad hoc maintenance plan, and then schedule your preventive maintenance, execute the maintenance, and identifying even after the preventive maintenance how much is the failure happening, and based on that failure, just to track that failure and then reschedule again adjust the preventive schedules to do the maintenance operations. So this being more of manual effort, which is more like a error prone, no data analyzed in this case. It's more of assumption based, ad hoc approach based practices. So it doesn't give the full reliability score or any way to measure the result of the reliability practice. So what is the result of that, right? So by traditional practice, even though there are traditional practices of reliability management, there are a lot of failures happening in the industrial sectors. So some of the statistics that shows that the cost of failure is over $800 billion annually across the larger and mid-sized asset management companies or companies which are heavily depending on the physical assets for their operations. So the traditional practice or unplanned operational asset operations are leading into more financial loss in terms of cost of operation as well as the loss of productivity. So both combined together is a significant value which should be addressed in using the newer technologies. So this is where we have to start leveraging the IoT and AI technology. But how? What is the role of IoT and AI in the reliability management practice? So let's take a first step in IoT. So IoT is a technology that helps to connect to the machines and start observing the machine conditions or health parameters or even runtime, production time, all the stuff. So monitoring the health asset usage and condition is a fundamental value that we IoT can bring that and automatically, right, in a real-time basis. So we can get those data and we can look at the data in real time. Also help us to identify the faults or fault codes based on the controlling unit of the machine or asset. How do we measure that fault codes that triggered by the control units, and how do we capture that and then send the alert to the operations team? Hey, this particular asset is throwing a fault code, blah blah blah, and this could be this reason. So this could be triggered automatically with the help of IoT device. And then locating the asset, whether the asset is in the proper location, either it's a fixed asset which are fixed in a particular location, or movable asset like a truck, or earth movers, mining equipments. So all of them can be geofenced and then tracked within the location for the safety of the asset, so using IoT technologies, of course. And then the streaming the data itself in terms of productivity data, like how much machine being utilized, what kind of a flow of the liquid pumping and things like that, can be measured. So IoT helps to connect to the physical machines or the assets and gather the data for different, analysis purpose. On the other side, AI technology are playing a major role in further enhancing the data by making decisions out of the data, such as based on the data gathered, detecting and triggering a preventive work orders, preventive maintenance, or finding anomaly conditions, such as suddenly a huge vibration is coming from the drilling missions. So that means there may be some different conditions. It's going through either internal parts failure or the earth components related challenges. So sudden anomaly detections help us to identify the conditions where the asset being utilized or used or operated, and then identifying the predicting the condition based on based on the historic events and the data gathered, predicting the condition of the asset and then triggering a preventive or maintenance operations. um, we can use the AI technologies to even prescribing a checklist to do the preventive down. Also identifying the issues and resolutions by knowledge gathered by the AI technologies. Also to automate the workflows in terms of automatically based on the incident and events, automatically triggering a different executions or operational tasks, or even correcting the system by itself. So those kind of things can be done with the help of AI, but AI depends on the data being generated by the IoT. So there is a data dependency, and that's how the condition itself is monitored. So typically the condition monitoring happens in a three-stage process. Machines get connected using sensors, gateways, and the hardware components, and the data gathered, connectivity established, so that the data can be gathered, and the data can be aggregated in the repositories where all this information captured and stored and persisted for a analysis purpose. So same data can be used to trigger the alerts, such as condition-based alerts or anomaly-based alerts when we want to trigger it. So IoT itself, help us to basically monitor the condition of the machine and triggering alerts for operational purpose. Whereas the same aggregated data can be used for different operational purpose. So the operational, maintenance operation or asset reliability operations categories as the four different way of doing it. First one is the preventive, which is a traditional approach, but we can still use the AI technology or the data that we gather through the IoT and AI to do a specific, preventive schedules, such as, data-driven preventive work orders or data-driven preventive work to conduct a maintenance operation. Or, based on the data, uh, to execute the preventive maintenance, we can trigger the anomaly detection. If anomaly detection is, suddenly detecting certain data beyond the trend, then it can trigger preventive maintenance. So the preventive maintenance can be achieved with the help of data-driven, condition-based approach, or anomaly-driven, work executions or maintenance execution. The next step is on the predictable maintenance. Preventive maintenance more reactive purpose, because it's happening, so we are going and executing a maintenance operations. Whereas in the predictive maintenance, it's based on the prediction value. How do we predict it? There are different algorithms available within the AI technology. One of them is could be a vector classifications, which identify the classifying each and every type of events happen in the mission. Based on that, identifying the possibility of happening, and then the predicting the date of occurrence, and based on the occurrence, triggering a maintenance work order even before that. So that kind of predicting the event even before data is coming from the based on the historic data. Second thing is logistic regressions, another approach which also helps to understand logically how these fault conditions are happening and how that can be aggregated over the period, and that could trigger a failure of the asset. So based on that algorithm can be triggered to can trigger a maintenance work order or a preventive work orders. A third one is the prescriptive maintenance, which is predominantly, based on the parts usage trends, how the parts being used, based on the fault type, the type of incident happens, and the site type of rectification done. And based on that type of trend, predicting, what could be the solution for the upcoming issues. So example, there could be a bearing issue that predicted to happen in a particular timeline, and that bearing issue should be replaced or prevented by using a gel liquid injection into the bearings, or some kind of a solution that can be maintenance solution that can be done before even that particular parts goes failure. So that kind of a prescriptive instructions can be given to the operators to prevent by itself. So operator can manage it, or the maintenance can manage it. The last one is autonomous maintenance, which is more of a instead of waiting for the maintenance team to do the maintenance operation, even the preventive operations, instruction based conditions or instruction based descriptions or information can be educated to the operator itself to do the autonomous, using the AGI kind of a technology, like advanced generative AI kind of a technology. Using that, we can give a prescriptive way, or even using Gen AI, we can put a prescriptive instructions to the operator itself to do the maintenance without depending on the maintenance specialized maintenance team. But we can also do the fallback workflows. Basically, if one component failing, the machine could be programmed to handle the backup components using the same AI technology, which is more advanced level of maintenance operations, which is more autonomous, means independently do it by itself rather than waiting for the maintenance engineers to come and do the work. So this is more advanced level, which is the direction that industry is going towards after the prescriptive maintenance. So all four type of maintenance operation can be addressed or can be done using the AI technologies in today's world. Now we are in the bump of generative AI, where everything is talking about the value of generative AI in every sectors, every industries. So even in the industrial operations, maintenance operations, or asset management operations, generative AI play a major role today. Number one is more on the instructive maintenance. Because the team may be knowledgeable on the asset that they operate on day-to-day basis, but they may not be knowledgeable on the global practice of the asset maintenance and best practices. So the generative AI help us to gather the knowledge and capture the knowledge, and based on the knowledge gathered, it can instruct the maintenance team to do certain step or the process to address a specific maintenance operation task or maintenance issues. So that is more instructive maintenance, which is more reliable, more standard across the team, so the knowledge managed across the team equally. So that is more advanced level of information that can be done, and we will talk about that little more today in our solution. And second one is decision support in terms of whether we need to go for preventive maintenance or we need to go for we have to wait for some more time. This kind of questions always always floating around in maintenance engineers in terms of the maintenance operations. So decision support can be much easier when we use the generative AI, because it's giving more more intelligent thought process on predicting or identifying the demand, forecasting the incidents, and then guiding the maintenance team to take decisions faster. So it is more supportive to the decision making. And then the knowledge transfer, which is more crucial in today's world, when the bunch of engineers from the different region, different locations, operating in a unified model, where the knowledge may be different from each and every executive maintenance engineers. So the knowledge should be transition, new people coming, and then the leaders are moving into different roles. So the knowledge cannot be wasted, carrying within the mind. So that should be carried forward to each and every team. So managing the knowledge repository within the generative AI using a content that created based on the history of the event, based on the history of the incidents, fall conditions, it can be measured and monitored, and even the knowledge is maintained within the system. So any newcomers coming to the practice, and they can easily understand the process in place, practice in place, and even guided references, they could follow the best conditions to that. So the knowledge transfer from equally to all the execution team will much streamlined with the help of generative AI technologies. So generative AI plays a major role in terms of reliability management aspect as well. In addition to that, when we talk about reliability management, there should be some way to measure it, right? So whether it is what is reliability means, what is reliable value is, how do I say that my asset is reliable or not, right? We should have some kind of a measurable value on that. So this is where we use a practice of health score, which gives the idea of what is the health condition of my assets, which is very similar to we go and do the health checks for our body, and understand where am I standing in, am I is there any prediction that I'm going to my health condition is degrading, what is my pulse parameters, what is my heart rate, what is my blood level, particles and other things and all. So this kind of a similar structure is what health score is. Health score is giving, indicating the health condition of the asset based on the historic events happen in the asset, based on the asset availability, and asset 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 maintenance operation standpoint. So one of the key formula that we use in this case is MTBF, and using MTBF and MTTR. So MTBF stands for mean time between failure, which means that between two failure conditions, the duration between the two conditions. So, and it could be based on the multiple events, in a 6 months period or 1 year period, based on that, how many incidents happens, how much difference between the failure conditions, we can come up with a mean value, and that mean value will help us to identify what is the tentative failure duration between one failure to another failure of the particular asset. And then the time takes to repair is the condition where the to repair that particular condition from the failure period, and how much it is operation condition, how much is failure duration, that should be measured. So MTTR is more of a time to repair the particular failure condition from the failure to the recovery stage. So that is the MTTR value. So based on these two values, we come up with a health score, which indicates in the percentage value basis to see whether the the health condition of the emission is on the above level or anything that we need to be really worried about. And we will see this in our demo today. So this is one of the way to measure the reliability condition of the every individual asset based on the failure trends. So in we have looked at the traditional way of asset reliability management, right? So that the advanced level of asset reliability management stands out, that we should use a technology available, which is IoT, predominantly IoT AI, to automate the data capturing, predict the asset reliability, and then execute the maintenance operations to increase the reliability score of the asset. So in that case, it's more of IoT and AI that drives the effective asset reliability management practice. So what steps we have to do that? So we have in the previous traditional approach, we have seen that you have to follow, you have to first schedule the preventive work, and then you need to measure it, right? It's a more of a reactive approach. Whereas in this case, in the modern approach, obviously identify the business critical asset first, and then identify the critical failure points on each and every asset. What could be the critical failure points? If that particular component fails, the whole system fails. That kind of detail level of pointers we need to identify. Connect the sensors to the failure points, because that's where we need to start with, and to identify the usage of those failure points on the critical point failure points to collect the data, monitor and predict the health score based on the condition of the data and the failure points and why that failure happened and what is the time it takes to address it. So the health score is predictable based on the critical points that we are sensing, because that's where the total downtime is impacting the overall performance. So then prepare a maintenance plan according to the health condition of the asset or health score of the asset, and then prepare a maintenance plan or trigger a preventive maintenance schedule based on the health score of the system as well as the health parameters of the system. So that then execute the maintenance operation. In this case, you do not need to put ahead of preventive schedule, unwanted preventive schedules, and then burning the cost of doing a maintenance without even understanding whether the incidents could happen or not. Here in the modern practice, it is based on the condition of the mission, score of the health score of the mission, as well as the failure points of the machine or asset. So based on that, we do that. So the practice itself is in a reverse model, so which helps to save time and cost of doing a unwanted maintenance operation, unwanted usage of parts and other things to prevent a downtime. So fogging asset platform offers a solution for this by bundling the maintenance process as well as the reliability management combined together in a single platform. So asset management is a core functionality which includes asset performance and maintenance operations and asset related scores and other things. Then execute the maintenance operation in terms of predictable condition-based maintenance or preventive maintenance. Also monitoring and measuring the performance metrics, a health score, and then prepare a predictable reports based on that. So asset plus platform or fogging asset platform offers all three combined together in a single platform. So you can do the traditional maintenance operations. You can also do the advanced medicine operations using the AI and IoT technologies. So the product, offering many different modules within that. The more critical things are, asset management, um, preventive and proactive maintenance activity, maintenance history, fault code tracking, metering based, IoT based metering to detect it, and then AI assistance. So we'll show you the quickly on that. The previous webinar also we have shown some of the features. Now we have enhanced some more features in the recent releases. So we like to show that here in the system on how we can do these preventive things. And it's a continuous journey. We are continuing to work on improving the overall reliability score, reliability practices through our system and process that we build within the system itself. So how IoT and fogging platform works together, because fogging is IoT, fundamentally is IoT infrastructure, which supports IoT connectivity. So in this case, for condition monitoring or even data collection process, we provide a asset condition monitoring kit, which basically a device that attach with assets to measure different condition of the asset, such as loudness in terms of the noise, current flow, vibration level, or temperature being produced by the environmental temperatures and all. So measuring all those data sets and use that based on that, do the conditions. This could be one of the critical point, or this could be one of the outline points. It depends on that, and this can be configurable to connect to the critical sensors to that as well. So these data sets, the device can send the data to the cloud application where the data processed, analyzed, and then it's triggering a performance access and performance mentions. So fundamentally, the platform is support end-to-end of that in a single application itself. So that's what we are going to see how we are handling it. So before I go back to this, let me take a step back and go to the demo, and I will show how our application works. Um, so in this case, this is our application system, which is accessible on the web, and anyone can register account and create account and try this out at credit card required or anything like that. You can register and create an account, and then you can try it yourself. But to do the advanced advanced tools, you probably need access to the trial versions, and you can reach out to us, and we can help you on that. So when you go to the Asset Plus application, obviously you can see a settings section. In the I'm going to show you how two things are going to work: how the IoT works, and then how AI works in the system, embedded inside the system. So if you go to the settings, you can see the IoT enablement practice. So here, you can declare the list of devices that you are attaching here. I already have a device which are connected. Example, I have this particular device which I've been connected with that, and this device configuration I have done it. So it's very simple to add a device configuration. You can connect to your platform by using API key, and that help you to connect to our IoT engine. And then in the device level, you can add a device in the device registry, activate the device. As soon as you activate the device appears here. And when you go to the device level, you can also declare what sensors that you have added in the device, so that you can measure the sensors based data. And these sensor values are critical to execute preventive condition based work order, or any maintenance schedule, or even understanding the trend of the asset health conditions. So you can declare any sensor value here by yourself, and you can start sending the data through that, and you can use your own sensors to send the data, or you can use the device that we provide, and that help you to connect to the machine without writing any programming or any other on the embedded side of work in your side. So once you have connected, it shows right now one of the devices connected. So now go to the asset, you can go to the asset and you can, example, I know I'm going to show this particular asset, where you go to the asset declaration, and while declaring the asset, you can declare the metering. And after metering declaration, which is basically where the IoT is coming, you need to go to the metering tab, and you can define your triggering points on that. So this is where we use the metering, which is obviously the sensor value, the vibration value, and then from which device this is coming. So this will show the device that you have configured. So I have configured oil pump device, and basically that's going to send the vibration data to me. And that based on the vibration condition, I wanted to trigger a work order. If in case there is a extreme vibration, anomaly, either it's anomaly detection or it's a trend based, incremental vibration. Either case, if I wanted to trigger a preventive execution, preventive maintenance, I can define the rule. Based on the rule conditions, it will trigger a work order. So you can see here, I have predefined what needs to be done here. And then, once you created this asset with the metering, then whenever the data comes into the system, you can see a work order trigger. Example, I just to show you simulation of this. Okay, let me go and see here in the metering. Okay, so you can see here, this particular one, we have a two IoT data is already defined recently. So let me go and trigger some more uh, records. So you can see that the previous record is 215 frequency. Now let me go and do that. So I'm using our inbuilt platform to do a simulation of the data. So let's take, I want to keep it as a vibration. Remove all other dummy records. So let's do that. I'm going to trigger this at 700 now. Okay. So so 700. So now vibration is 700 for this one. I'm simulating this data. As soon as I simulate the the data comes here in the platform, because I pre-configured this with the metering. Whenever it is exceeding that 700 data, it should create a work order here. So, okay. So now we go here. It's creating a work order here. This work order is automatically created as an on-demand work order based on the vibration conditions. If you go to the execute work order, you can see that vibration condition is exceeding, and then the note itself, whatever I declared as a note, I know that's triggering it. So now this work order is triggered. Now let me complete this work order. Let's take, I wanted to complete this work order. Okay, I started it. Let me start investigating it. Okay, so then I put the history on that. Now the work order started progressing. It means I started working on this. So this is how, I started practicing it, even based on the data. But how do we know the reliability, right? So the reliability is very important point, because as a maintenance engineer, I wanted to understand the reliability of that. So for that, for the same pump, we have a reliability, we have as a 360 view. This is a new feature that we recently launched. This 360 view gives all aspect of that asset and its informations. The first section of the 360 view gives you the basic information about the asset in terms of the asset information, like a brand, usage, and what kind of asset is there, what kind of material is this, and how long its usage level, expectation level, work hours, and all things. Also, you can see the parts that associated with this asset. In case any maintenance I had to do, that I can do based on these parts availability and conditions. So that also is associated with that. Then you can also see the maintenance conditions, how many maintenance we have done it, how many preventive maintenance, how many fault maintenance we have done for this particular asset, and how many inspection type of maintenance we have done it. So based on the history of the maintenance activities done on this. So this provides you the list of maintenance activities conducted in this itself. And then then the next option, because it's based on the reliability, is based on how we are doing executing different things. So now, based on the previous conditions and in previous failure conditions, preventive conditions, and then other scores, health scores, the reliability tab provides the reliability score of that. As we saw, the health score is an important value to understand the reliability of the system. So health score gives idea about what is this this. So this is based on the formula by itself. So based on the MTTR value and MTBF value. The previous fault condition triggered, it took some time to rectify it. It took 24 hours, 54 minutes to fix the issue from the downtime. So which obviously added a 21 hours of downtime based on this. And then the mean time between failure is, between 138 days once this particular six. And based on these conditions, you can see the health score is become 98, which is very good probably. It depends on that because the number of faults happening in the system. So also you can see that that the availability of that for the last 6 months period. So you could see that for April and May there is a low availability score due to the incident, to the failure happened on those things. So it depends on your asset conditions. You can monitor the availability score as well as health, the overall health score of that. Now going further down, we looked at the prescription based, right? So going further down based on the failure conditions, based on the maintenance operations, what parts we have used to for the preventive maintenance also, this particular chart shows the number of components we have used and the cost of those components and which is the highest component that we are using it, and that's a value on that. So the cost of those components are showing here. We have used 40 oil heavily for all the preventive maintenance on that particular asset. And then the belt conditions have been replaced maybe one time, and then the cleaning cloths used several times. So this kind of metrics, it shows the linear value is there, but it is very, very low value on that. So anyway, so this is how we can even identify the trend of the parts usage. The same way fault occurs. Right now, only one fault occurs in this data that I have here. But if you have a multiple faults occurs, then this started showing the value on that. So by looking at the reliability score, we understand what we have, where this is standing, and by scheduling the maintenance operation automatically based on the anomaly detection or the condition detections, we can also trigger a work order without human intervention on that. So all of them is based on the IoT data. As you can see here, there is a IoT data came in. I simulated the data. I received the data here. I can also go and look at the data, what data received, when, what's the previous value, and what time and period and all. So this helps me us to understand that trend of that metering and how this vibration data varying from time to time and why it is triggered a work order now. Now, we also have, now the question is, how we are going to use the AI into this, right? How we can leverage the AI technology here. So we have a different way to do that here. We already embedded the anomaly detection as well as the condition-based detections in the declaration level itself. So it's happening in the backend side. But as a maintenance engineer, you can also use the generative AI technologies, right? So we also embedded the AI, generative AI, to help us to understand more into this. So now you can see here, this is our co-pilot inside the application itself. Now, as a question of 700, right? 700 frequency, right? So now I'm asking question, what is the solution? What is the acceptable vibration value? Vibration for 12 HP pump. So, when I'm asking, this kind of, questions, then generative AI or the AI technology help me to understand it. So it's giving me, descriptions on how I should address, what I should understand and how I can address it. Example, this one is showing like, this should, as per the ISO standard, the pump node vibration velocity limiting to 2 mm to 12 mm on depending on the frequency. So now I can take this data and understand, okay, maybe that is what we need to look at here. So and based on that we can do some corrections on that. Or I may say that just to copy this and copy this content and then go to the execute work order. And then I can say that, okay, this, okay, oh, I lost it. Okay, I can do it here also. Um, ISO standard 2 mm to 12 mm required. Okay. Then I can put that comment also into that. So now it's getting updated in the system. So the process is in, triggered on that. Even if I wanted to do that, like example, another way to helping this is, the vibration is not showing in the meter placed in mission. So I can rewrite it, and that gives you more clear visibility on that. So now I can say that let me take 1 hour I worked here, um, and then submit it. So this also getting added into that. So now, based on this, we can use the technology that we provide here, help us to understand in the prescriptive way, as well as it help us to, trigger the automated, work order scheduling. And then also I can go and look at the assets health scores. And based on the health score, I can understand where this particular asset is there and what kind of conditions it's going through that. So this helps me to plan my scheduling and preventive scheduling or reliability scheduling to execute effectively. Let me go back to that. Okay, now, okay, so how we helped in a customer, in terms of reliability management practice, or reliable asset reliability management aspect of that. So one of our premium customer, in a recycle management, heavily utilizing the conveyor belt, balers, and other equipments, and to do the recycling process and all. So one of the critical thing here is the maintenance operations. So they were doing regular maintenance, which is more of a, scheduled maintenance, without, having a value on that. So we help them to bring the practice. Basically, help them bring the practice of, following reliability management with the help of our equipment and devices. So that way, they started measuring the data coming from the conveyor belt motors, baler motors, which are crucial for their operations, and then predicting their values, and then scheduling a preventive and proactive maintenance based on that. So that helped them to reduce the ad hoc maintenance process, ad hoc usage of parts and other things without even incident happening and things like that. That also helped them to reduce the overall operational cost on a annual basis. So with that, what is the best practices? I talked about this in the previous webinar also. I like to re-emphasize this again, because we are talking about advanced practices in reliability management. So leveraging IoT is crucial in today's world. Especially the technology is very affordable today, and it can be quickly added to any equipments, machines, or larger heavy equipments and machineries to measure the critical points and diagnose the issues. AI help us to understand the data, predict the conditions, and then triggering a automated work execution process. And um, following the reliability practice to prevent the failure on that. um, Asset management software or asset operation management software um, helps to streamline this process without manually going and writing and triggering it. Obviously, not just having IoT and AI technology alone helps. That should be embedded inside the process itself to streamline this. So that's why we combined the CMS software or maintenance management software with the AI, asset condition monitoring, asset performance monitoring, and the AI predictions together to make it as a more process driven approach rather than in the ad hoc incident-based tracking approach. So that gives the true power to the maintenance team to leverage this technology within the system that they are accessing without having a full technical knowledge about AI understanding. They still can use this as a process system to leverage this technology and execute the activities effectively. So that's a four key things that critical for the modern way of asset reliability management today. With that, I would like to hand it back over to Prasad. So Prasad, over to you.
Thank you, Hari. Thank you for the deep insight. We have a few questions. I will be reading them one by one, and you can respond to them. So
Sure.
the first question is, does Asset Plus has a trial period available or any free version available to try the platform?
It's available, free version is available. With the limitations, you may not have a IoT connectivity on the free versions. The free version is basic level of functions, more into the maintenance operation standpoint. If you want to IoT based connectivity, you can contact our sales team, and they will provisioning a trial version for a trial period to experiment it.
Okay. The second question is there any mobile application available for Asset Plus?
Yeah, so there is a mobile application available, which is predominantly for the maintenance engineers, and to operate on a day-to-day, they can access the asset, they can access the asset health conditions, whatever you have seen as asset 360, right? So the reliability score, health score, the parts usage, all of them is part of the mobile app itself. So they can go and access the asset on the field itself. They can just open the app and check the condition of the asset and its score, and then they can take action on the field level itself. So it's available.
Okay. So that was all the question we had. Thank you, Hari, for answering all the question. I hope it was helpful for all who have asked and for other as well. Now I think it's time to wind up the webinar. As previously stated, we will be uploading the recorded version of this webinar to our YouTube channel. Therefore, you can also visit our YouTube channel to watch this and our past webinar sessions. For those who are interested in gaining further insight into IoT, Industry 4.0 and smart factories, we encourage you to explore our blog section at www.fogwing.io/blogs. Additionally, if you are seeking collaboration opportunities, please don't hesitate to contact us at sales@factina.com. Thank you once again for participating in this session and contributing to its success. We eagerly anticipate connecting with you in our next webinar. Stay tuned and have a wonderful day. Bye-bye.
Thank you, everyone. Bye-bye.